human neural system here. Next. So in our human body, all vital activities, it means all our body activities, they are controlled and regulated by in our human body, all body activities means all vital activities. All vital activities means like respiration, digestion, circulation, etc. So all these body activities are controlled and regulated by means of two systems. What are those two systems means here? One is neural system, and another one is endocrine system. So in our body, all our vital activities are controlled and regulated by two types of systems. One is neural system and second one is endocrine system. What is this neural system means here? This neural system, it provides point-to-point connection. It provides point-to-point connection. What is the use of this point-to-point connection means here? It provides a fast response or it provides a fast coordination. So this is known as neural system. And second one is here endocrine system. In this endocrine system, the activities are regulated by means of chemicals or chemical integration. Chemical integration. That chemical integration is called hormones. So those chemicals we are calling as hormones. So like this, all our body activities are regulated by means of these two systems. Next. So human neural system, it has divided into two parts. One is central nervous system and second one is peripheral nervous system. What is central nervous system means here? Central nervous system, it is present mid-dorsal line of the body. It is present at the mid-dorsal line of the body and it constitutes brain as well as spinal cord. Human neural system, it has two divisions. One is central nervous system, that is CNS, and second one is peripheral nervous system called PNS. What is CNS means? This is the nervous system which is present longitudinally. It is present longitudinally along the mid-dorsal line of the body and it consisting of brain as well as spinal cord. What is the role of this brain and spinal cord means here? It it acts as a information center and processing center also. Next, peripheral nervous system. What is peripheral nervous system means? The nerves, all the nerves which are arised by CNS here. So what is this peripheral nervous system means here? This is the nervous system which is present at periphery of the body, and it constitutes all the nerves which are derived or which are arised from CNS. For example, the nerves which are derived from brain is known as cranial nerves, and the nerves which are derived from spinal cord, they are known as spinal nerves. So in the human body there are 12 pairs of cranial nerves and 31 pairs of spinal nerves. This one. So here this is brain. So this comes under CNS. So this is the brain and this is spinal cord. And whatever the nerves which are arised from the brain is known as cranial nerves, and whatever the nerves which are arised from the spinal cord, it is known as spinal nerves. Next. So this nervous system actually present in only higher organisms or even in lower organisms. Actually the neural system is also observed in lower organisms also. For example, this is NCERT line, important point. In lower invertebrates, the neural system is primitive. It has a primitive neural system. Example. What does the example means here? For example, Hydra. Hydra belongs to which phylum? Hydra belongs to which phylum? Yes. So the Hydra which belongs to coelentrates. The first time the nerve cell has evolved in Hydra only, but in this Hydra the neurons are present. Neurons are present in the form of nerve net. In the form of nerve net. That's what we are calling it as primitive neural system. Next, what about next organisms here? If you take in insects, insects comes under phylum Arthropoda. In the case of insects, it has better organized. This is statement question. It has better organized system. Which organisms are having primitive means Hydra, and which one has better organized neural system means here, that is insects or Arthropoda. Why do we are calling it as a better means? Because in insects it has brain, along with it has ganglia and neural tissue. Comparative to Hydra, here it is little bit better organized here. Next, last one is here higher organisms. Higher organisms means including human beings, that is vertebrates. What about in higher vertebrates means? In the higher vertebrates, the neural system is Is it complex or simple? It is complex. Neural system is complex and well developed. And well developed here. So we can see this type of neural system from lower invertebrates to higher vertebrates also, but their organization is different. Next. Next, human neural system is classified into two divisions. Already we have discussed. Number one is CNS and second one is PNS. It means peripheral nervous system. What does this CNS consist of? The CNS, it consists of brain as well as spinal cord. So these two comes under CNS and PNS. In this PNS, it has again divided into one is somatic neural system and second one is autonomic nervous system or neural system. What is the role of this somatic as well as autonomic nervous system means here? This somatic neural system, it relays impulses. It relays impulses from, this point is important point, it relays impulses from CNS to skeletal muscles. Here, what type of muscle is skeletal system? What type of muscle is skeletal muscle here? It is a type of voluntary muscle. It is a type of voluntary muscle here. So somatic neural system, it relays impulses to skeletal muscles. It means voluntary muscles. So for that reason, this somatic neural system is also known as voluntary neural system. And autonomic neural system, it relays impulses from CNS to, these are NCRT lines here, CNS to involuntary organs and smooth muscles. And smooth muscles here. So which of the following neural system provides or it relays impulses from CNS to involuntary organs? What is involuntary organ? For example, it is heart. Heart here. So which of the nervous system relays impulses to heart as well as smooth muscles? Even the smooth muscles are also involuntary in nature. So for that reason, the autonomic neural system is also known as involuntary neural system. Next, this autonomous neural system, it has subdivided into two. One is sympathetic neural system and second one is parasympathetic. and both this neural system, they works antagonistic to each other. Antagonistic to each other means they works opposite. For example, sympathetic nervous system increases the heartbeat. Whenever it will act on heart, their role is sympathetic neural system, it increases the heartbeat. Next, the role of parasympathetic, it decreases the heartbeat. It means exactly they works opposite to each other, that is known as antagonistic in nature. So this is about classification of human neural system. Next, along with this, one more neural system is there, that is known as visceral neural system or visceral nervous system. So what are the points comes under this visceral means here? Number one, visceral nervous system, it belongs to, question is, it belongs to CNS or PNS. What is the answer? The answer is PNS here. So visceral neural system, it comes under category called PNS. Next, what is this neural system? This neural system, it comprises number one, fibers, it means nerve fibers. Second one, nerves. Number three, ganglia. And number four, plexus. Here. So these four are present in visceral neural system. And next one. And what is its role here? The role is here, it also relays impulses, same as that previous neural system. It also involves in relaying of impulses from CNS to visceral organs and visceral organs to CNS. It means it works in two ways. This is known as visceral neural system. It belongs to PNS and it comprises fibers, nerves, ganglia as well as plexus. And the role of this neural system is here, it relays the impulses from CNS to visceral organs or viscera and viscera to CNS here. Next. So this is actually nerve. This is actually nerve. So what is nerve means? This is a peripheral nerve, because the nerves comes under PNS. So it is a peripheral nerve here. So this peripheral nerve is a bundle of fascicle. It is a bundle of fascicle. So what is fascicle means here? Fascicle, each fascicle is again a bundle of nerve fiber. Nerve fiber. So where do you can find this type of nerves means here? It is present in cranial nerves, that is derived from the brain, as well as in spinal nerves. Next. So our human neural system is made up of, which tissue? Any idea? It is made up of which tissue? Which tissue here? Tell me which tissue? Humans have four types of tissues. No? So out of that four, our neural system, which is made up of neural tissue. So this neural tissue is derived from ectoderm. It is mainly derived from ectoderm, and this neural tissue consists of two types of cells. What are those two types of cells? One is a highly specialized cells. This is also NCERT line. It consisting of a highly specialized cell called neurons. Highly specialized cells called neurons. And second one is here supportive cells. And second one is here a supportive cells. These supportive cells are known as neuroglial cells. For example, human brain consists of approximately 100 billions of neurons here, and along with neurons even neuroglial cells also present. But whose population is more means here in another chapter given in the NCERT, neuroglial cell population is more, and it constitutes, this is very important, it constitutes more than 50%. It constitutes more than 50% of neural tissue. Okay, anyway, our here nervous system is made up of neural tissue, which consisting of two types of cells, neurons as well as neuroglial cells. Is there any difference between these two cells? Is there any difference between these two cells? Anyone knows means you can say. Number one, these neurons are excitable cells. These are excitable cells. What about neuroglial cells? Neuroglial cells are non-excitable cells. This is the major difference between two cells here. Neurons are excitable cells, whereas neuroglial cells are non-excitable cells. And one more point. These neurons act as structural and functional unit. It acts as a structural and functional unit of nervous system. So why do we are considering these neurons as structural and functional unit? Please give answer. Why do we are considering the neurons as structural and functional unit of neural system? Because this neurons has a special ability here. What is that ability means? These neurons can, this point is very important point in statement question. These neurons can detect and can receive and can transmit these neurons. Why do these neurons acts as a structural and functional unit means here? Because it can detect, receive and transmit. Same impulses are different impulses. It transmits different stimuli. Different stimuli here. So this is very important point. Next one, what is the role of neuroglial cell? This is actually acts as a structural and functional unit. And what is the role of this neuroglial cells means here? These neuroglial cells, they perform support. So they may be supportive and some will nourish us and some involves in nourishment and some will involves in protection. It means phagocytic in nature. Here. So that is the role of neuroglial cells. And one more major difference is these neurons cannot regenerate. They cannot regenerate. Very important point. But whereas neuroglial cells, they can regenerate. The major differences between these two are, one is excitable cells and these are non-excitable cells. These are the structural and functional unit because they have a capacity to detect, receive and transmit the different stimuli. But whereas these neuroglial cells, they plays an important role in supporting nourishment or phagocytic in nature. It means they are going to support the neurons or they can repair the neurons also. And next one is the neurons drawback is here, they can't regenerate, but whereas neuroglial cells can regenerate here. Next, This is the neuron. So what are the parts present in neuron means here? In NCERT, they have given neuron is a specialized cell and it is a microscopic structure. It is a microscopic structure made up of three major parts given. Underline three major parts. What are those three major parts means here? Number one, cyton. What is cyton means? The cyton is nothing but a cell body. Cyton or cell body. This cyton is also known as perikaryon. And even it is also known as soma. This is the first part. Second one is here dendrites. And third one is here, third major part is known as axon. Okay. So the first one is cell body, cyton or soma or perikaryon, and second one is here dendrites, and third one is axon. What is the difference between these three means? Number one, cell body. This is just like a typical cell here. It consists of cytoplasm. Inside, and next it has cell organelles also, like it has nucleus and other cell organelles. Cell organelles means which one? Like mitochondria, Golgi, endoplasmic reticulum, etc. And even it contains nucleus as well as cell organelles. And next one, cell organelles, and next one but it lacks one organelle, that is known as centriole. This is very important. It has all cell organelles except centriole. In the previous slide I said that neurons can regenerate, but whereas neuroglial cells can't regenerate, but whereas neuroglial cells can regenerate. Why do the neurons cannot regenerate means here? The reason is they lack centriole. And next one unique feature of this cell body is it has Nissl granules. What are these Nissl granules means here? These are the structures which are composed of endoplasmic reticulum plus ribosomes. Then what is the role of this Nissl granules? This Nissl granules plays an important role in protein synthesis. Okay, they are also acts as a rough endoplasmic reticulum which plays an important role in protein synthesis. So this is about cell body. Next one is here dendrites. What are dendrites? Dendrites are NCERT line. These are short fibers. Which branched repeatedly. Which of the following fibers branched repeatedly means the answer is here dendrites. Branched repeatedly. And the next one, they are arised from cell body only. They are arised from cell body. Okay, what is the role of this dendrites means here? This dendrites, it acts as a receivers. It acts as a receivers, and the role of dendrites is here, they are going to receive the stimuli. So these dendrites, they will receive and then they can transmit the impulses. Important point this one. And it transmits the impulses towards the cell body or away from cell body. Answer is towards. They are going to receive, after receiving, they are sending the impulses towards the cell body. This is very, very important point. And next one, even this dendrites also has Nissil granules. Nissil granules. Suppose question is here, where do the protein synthesis takes place in neuron means here? The answer is cyton as well as dendrites, because these two structures has Nissil granules which plays an important role in protein synthesis. And next one is axon. These are short fibers, but axon is long fiber. It is a long fiber and mostly it is single. And next one, this long fiber also arised from cell body, just like dendrites. They are also arised from cell body, and their role is here, they conduct. Actually, they are involving in conduction of impulses. It conducts or it transmits impulses. It transmits impulses away from cell body. These 2 points underline, important points. Which of the following structure plays an important role in transmission of impulses away from the cell body means axon, towards the cell body means here the answer is dendrites. And next one, here this axon lacks Nissil granules. This is important point here. So which of the following structure of neuron lacks Nissil granules means the answer is axon. Which one has means the answer is cyton as well as dendrites. So this is the structure of neuron which acts as a structural and functional unit. So this is cyton. This is cyton, and these small structures, these fibers are known as dendrites. And next this long fiber is known as axon. It is known as axon. This is nucleus. And all these small dots are neuroglial cells. These are the glial cells. Next. So these are the glial cells here. In the case of central nervous system, there are 4 types of glial cells are there, and in PNS, that is peripheral nervous system, there are 2 types are there. What is the role of neuroglial cells means here? I said now it plays an important role in nourishment, protection, or even supportive in nature. For example, microglial cells. Microglial cells are the smallest glial cells, and their role is phagocytic in nature. They are actually phagocytes. And next one is here ependydermal cells. These ependydermal cells which lines the cavities of the brain, that is known as ventricles, and they involves in secretion of cerebrospinal fluid. Here. Next, oligodendrocytes. The role of oligodendrocytes here, it involves in myelin sheath formation. It involves in myelin sheath formation. And what about these astrocytes means? These astrocytes are the largest cells and their role is supportive in nature. Next, here Schwann cell. The Schwann cell is also a type of glial cells, but it is present in the peripheral neural system. What is the role of this Schwann cell? Means even the Schwann cell also plays an important role in myelin sheath formation. This is very important point. Which of the following cell plays an important role in myelinogenesis? Myelinogenesis means myelin sheath formation, means we can answer oligodendrocytes as well as Schwann cell. But which glial cells involves in myelinogenesis? In PNS means answer is Schwann cell. In CNS means the answer will be oligodendrocytes. Next, this is the one already discussed. So this is dendrites, and this is cyton, and this is axon. Axon here. So always the impulses, they are carrying from which side to which side means here. First, the stimuli will be taken by dendrites, and from the dendrites it will release the impulses to cyton. From the cyton, the impulses will release through the axon. So this type of flow is known as unidirectional flow. Unidirectional flow. So this flow is important. So what is that unidirectional flow means? Dendrites to cell body and cell body to axon. Cell body to axon. This is known as proximal side and this is known as distal side. The distal end of this is distal end. The distal end of axon is branched and these branches are known as telodendria. It is known as telodendria, and this telodendria, it has a swollen structures like this. It has a swollen structure. These are known as synaptic knobs. These are known as synaptic knobs, and these synaptic knobs will have some vesicles. These vesicles are known as synaptic vesicles and which are enriched with neurotransmitters. So this is the distal end structure of axon. Synaptic knobs will be there and each synaptic knob will have synaptic vesicles, and these synaptic vesicles are filled with some neurotransmitters. Next, here classification of neurons. There are two types of neurons are there. Number one, this is known as unmyelinated neuron, and this is known as myelinated neuron here. So there are two types of neurons are there. Important topic here. So what are the differences between these two neurons means here? Number one, main difference is myelin sheath. The myelin sheath is absent. There is no myelin sheath in the case of unmyelinated neuron. Whereas in this case, the myelin sheath is present. This is a major difference. Next. In the last slide, I said who involves in the formation of myelin sheath, that is glial cells. What are those glial cells here? Here Schwann cell. This one is a Schwann cell. Schwann cell is it present or absent? Means it is present. Schwann cell is present and it plays an important role in myelin sheath formation. It means myelinogenesis. It involves in myelinogenesis here. And what about this unmyelinated means here? In this case, there is Schwann cell present or not? Even here also Schwann cell is present. Even in this case also Schwann cell is present, but not involved in myelinogenesis. Here, it's not involved in myelinogenesis. And next, here some gaps are there. In this case, the myelin sheath is discontinuous. It is discontinuous and it contains some gaps, and these gaps are known as nodes of Ranvier. Nodes of Ranvier. So where does the nodes of Ranvier is present means it is observed only in myelinated neurons. And where are these myelinated neurons are present means, important point, it is present in spinal nerves. It is present in spinal nerves as well as cranial nerves. Cranial nerves. And next one is unmyelinated or non-myelinated neuron. Where are they present means, these unmyelinated, it is present in autonomous, NCERT line this one, autonomous and somatic neural system. Somatic neural system. And what is the benefit of this unmyelinated and non-myelinated means here? Here the impulses are traveling very slow. So this is slow conduction. So which of the following neuron plays an important role in slow conduction means here? The answer is unmyelinated neuron. And what is the benefit of having this myelinated neuron means? The impulse is going to jump from one node to another node. One node to another node. For that reason, it plays an important role in fast conduction. For that reason, our spinal nerves as well as cranial nerves, they are made up of this myelinated neuron. So this is fast conduction, and whereas here, this is slow conduction here. And this type of jumping of impulses from one node to another node is known as saltatory conduction. It is known as saltatory conduction here. So why do the impulses are jumping from one node to another node? Why do it is not passing through the myelin sheath means? The myelin sheath acts as electric insulator. It acts as an insulator. For that reason, these electrical impulses, they are jumping from one node to another node here. Yes. Okay, remaining topic will continue tomorrow. Thank you very much.
Hey everyone, very good morning to all of you and welcome back to our journey in which we are going to learn a lot of fundamentals, and sitting back at home we can definitely prepare up to a great extent for our actual goal, that is the NEET 2025 exam. Yeah, good morning, good morning. Hope you had a nice lecture. What did you learn? I think zoology, right? Chaliye. So I think we can start here. Last time when we met, so we have studied a very beautiful component of motion in a straight line, and that is Galileo's formula. And I have told you and I have shared many NEET PYQs, if you remember, that generally we have our interpretation that every motion question we will try to do by the equations. Yes, we can do that. There is always one standard method to do the things. But as far as NEET examination is concerned, the battle is with time too. Okay. So if you want to perform well in a battle against time, then definitely you should have some quick learning techniques as well as quick solving techniques along with you, out of which one of the techniques of solving the motion questions, especially the motion under gravity, because I told you that Galileo's formula is applicable for motion under gravity as well as the other cases of uniformly accelerated motion where the body starts from rest. So today, similar to that, a very another interesting topic, very beautiful topic we are going to take, in which students are generally getting confused regarding the centripetal, centrifugal forces, these terms, and the circular motion. Okay, so today the topic of discussion is dynamics of circular motion. Dynamics of circular motion. Okay, so dynamics may we are going to talk about centripetal and centrifugal forces, but before talking about the forces, we have to understand the types of acceleration, how the velocity varies, and which type of acceleration is responsible to vary exactly what. I mean, the variation of magnitude will result in a simple one type of acceleration, and the magnitude of direction of velocity will result in some other type of acceleration. So we will see them one by one. So for example, a simple note for us that if I talk about a normal velocity vector, then velocity vector can be written as the product of its magnitude as well as direction. Everyone understands that modulus gives you the magnitude and cap, unit vector, gives you the direction. Modulus gives you the magnitude, unit vector, cap gives you the direction. So if you are going to differentiate it, suppose I say differentiate it with respect to time. Differentiation means the rate of change of one variable with respect to the other. So differentiate with respect to time. So what we are going to get? We will get dv vector by dt, and that will be equal to, see, by product rule I should differentiate. I should say the differentiation of the first one, d mod v by dt. The second one as it is, v cap as it is, plus the first one mod v as it is, and it is dv cap by dt. Now, if you understand it carefully, the physical significance, what does that mean exactly? Then what do we understand is the LHS term dv by dt. dv by dt gives you the time rate of change of complete velocity. Means with time, if the velocity changes, then whose responsibility is to change that complete velocity with respect to time? So you will say dv by dt is the net acceleration. dv by dt is net acceleration. Means what, sir? Means that it is the responsibility of net acceleration. It is the responsibility of net acceleration to change the entire velocity vector, to change the complete velocity vector. And if you talk about the first term in the right hand side, it is time rate of change, like how the magnitude of velocity is changing with time. So whose responsibility is to change the magnitude of velocity, means changing the speed, that is tangential acceleration. And see, if this dv by dt comes out to be positive, then the tangential acceleration will have the same direction as that of velocity vector. And if this dv by dt comes out to be negative, then the tangential acceleration vector will have the same direction as that, will have the opposite direction as that of velocity vector, which means this term can be written as tangential acceleration. Tangential acceleration. The first term on the right hand side is tangential acceleration plus whose responsibility is to change only and only the direction. So whose responsibility is to change only the direction? This type of acceleration will be called as centripetal acceleration. It is always towards the center. Centripetal means center seeking. Centripetal means center seeking. It is always directed towards the center. Or another name to that is normal acceleration, because the velocity, it is always directed, this acceleration is always directed perpendicular to the velocity. Velocity is always tangential, and the second type of acceleration is always perpendicular to the velocity, and that's why normal acceleration. Or another name to that is radial acceleration, because that is directed along the radius. So along the radius, radial, towards the center, centripetal, perpendicular to the velocity, normal. So every name you are giving that has some logic. Okay. I hope this is clear to you. Fine. So basically what we have learnt is that in case of circular motion, the net acceleration will be the vector addition of both, or you can say the combination of both. So net acceleration's responsibility is to change the velocity vector, tangential acceleration's responsibility is to change the magnitude, and centripetals or normal or radial's acceleration's responsibility is to change the only the direction of velocity. Okay. Now another thing regarding that, what is important regarding them is that these two accelerations don't interfere, that these act independently. They have independent responsibilities. They don't intervene in each other's responsibilities. They have independent responsibilities. Okay. So in case of circular motion, the speed may or may not change. In case of circular motion, the speed may or may not change, but the direction will definitely keep on changing. So what you can say is that they have independent responsibilities, but regarding the tangential acceleration, you can also conclude that this may or may not be present. May or may not be present. Why so, sir? Because if speed of rotation is moving in a circular path, or revolution is changing, then you will say it may be present. If the speed is moving, speed with which the particle is exhibiting the circular path, its speed is not changing, then you will say it will be absent. It will be absent. So its responsibility is to change the speed, but speed may or may not get changed. Hence you can say it may or may not be present. But this type of acceleration, if you talk about the radial, normal or centripetal acceleration, you will say this must be present, because this must be present in circular motion. We are talking about circular motion. So speed may or may not change, but the direction will definitely change. So if the direction is definitely changing, the centripetal acceleration is definitely there. The speed may or may not change, the tangential acceleration may or may not be there. I hope the basic idea is clear. Alright, and they don't interfere in each other's job, which means whether the speed is changing or not changing, that will not be controlled by centripetal acceleration, and whether the direction will keep on changing or not changing, which means that has to change although, but that will not be controlled by tangential acceleration. Okay, these two have independent responsibilities. As one is tangential, one is radial, so you will also say that tangential acceleration is always perpendicular to the centripetal acceleration. Tangential acceleration is always perpendicular to the centripetal acceleration, and for us to understand this clearly, what we can assume is that suppose the particle is moving in a circular path. Suppose the particle is moving in a circular path like this. Okay, so here is my particle as of now. Here is my particle at point P. This is my particle. It is moving in this direction. I mean, if you try to see this is the radius, this is the center, this is the radius, and about the center the particle is suppose moving in a clockwise sense. Then I will say the velocity at this point will be Vp cap. The velocity at this point will be Vp cap. Suppose that I am trying to mention all the accelerations. So there will be one acceleration which will be definitely AC. One acceleration which will be definitely AC, centripetal acceleration will be there. This must be there. Centripetal acceleration must be there. Why so, sir? Because its responsibility is to change the direction, and the direction of velocity obviously keeps on changing. Here the velocity was directed when the particle was here. Its velocity was somewhat like this. When the particle comes here, its velocity is somewhat like this. So the direction of velocity definitely keeps on changing. We are going to talk about the magnitude, but as of now I said that the direction will surely keep on changing. And who changed the direction? The centripetal acceleration changed the direction. Okay. So if centripetal acceleration changed the direction, that must be there, must be present, as I have written there. Another type of acceleration is tangential acceleration. As of now, I am representing that tangential acceleration is in the forward direction, supporting the velocity. So here I will mention that may be absent, may be zero also. Maybe zero also, means may or may not be present. But as of now, let us assume that tangential is also there, centripetal is also there. Both are already perpendicular to each other. And if you want to get the net acceleration, you will say, let us do by parallelogram. Let us complete the parallelogram and let us draw the main diagonal. So this main diagonal is going to give you the net acceleration, and let us suppose making a certain angle. Let us suppose making a certain angle phi with the velocity. Let us suppose making a certain angle phi with the velocity. So I will say here, number one, net acceleration's magnitude will be given by under root of AC square plus AT square. Net acceleration's magnitude is given by under root of AC square plus AT square, where centripetal acceleration or radial acceleration or normal acceleration. Centripetal or radial or normal means the same. That is given by V square by R or omega square R. V square by R or omega square R. Okay. This is the formula for centripetal acceleration, and tangential acceleration will be given by dv by dt, rate of change of speed, or that can be written as R alpha. So what you have to understand is, here if we talk about the omega, then the name of omega is angular velocity, or here it is angular speed. And if you talk about R alpha, the name of alpha is angular acceleration. Okay, the story is not yet completed here. Once more I will tell you that. But before that, first of all, what we have understand from the diagram is, first of all, the magnitude of net acceleration is given by this, and second of all, the direction of net acceleration. For direction we will talk about phi. So tan phi will be perpendicular by base. The perpendicular from the diagram will be given by AC, and the base is AT, or you can say phi will be tan inverse. Omega square R by R alpha, or you can just use any of the magnitude, any of the formula. I'm just writing it as AC by AT. This is the value of phi. I hope a basic idea is clear. Once more, today's target is to talk about the dynamics of circular motion, which means kinematics may we talk about the motion, dynamics may we talk about the forces responsible to create the motion. Okay, which means in dynamics of circular motion, we are going to talk about the forces which are responsible to make a particle move in a circular path. So in order to understand the force, we can also talk about the acceleration, and what we have learned as of now is that whenever a particle exhibits a circular path, it is having two types of accelerations. One of the acceleration is centripetal acceleration, whose responsibility is to change the direction. Another one acceleration is tangential acceleration, whose responsible to change the magnitude. Now, if a particle is moving in a circular path, its magnitude of speed, speed of rotation, magnitude of velocity may or may not change. So, tangential acceleration may or may not be present. Tangential acceleration will be there if the speed is changing. If the speed of rotation is constant, then tangential acceleration is also zero. No responsibility of tangential. And centripetal's responsibility is to change the direction of velocity. The velocity will always keep changing, and hence centripetal acceleration has to be always there. The moment you talk about circular motion, that very moment you understand that the particle's direction of velocity will keep on changing, and hence the centripetal's acceleration's presence is actually mandatory. It has to be there. I hope this much is clear. Another thing is, I have just represented one diagram. I will take it up once again to tell you the types of circular motion. The types of circular motion themselves, it's a uniform circular motion in which the speed of rotation will not change. It can be increasing speed circular motion, it can be decreasing speed circular motion. Many things can be there. One by one we will talk about all of them. But tell me as of now, is this clear to you? Is this clear to you? Particularly, another note what I am writing for you is, I have written a lot, but I have written a lot on this board to give you the clarity of a lot of things. Now see what I will say. Centripetal acceleration's magnitude is given by v square by r. This may be constant. Why, sir? Because in circle the radius has to be constant. If speed is constant, then centripetal acceleration's magnitude is also constant. If speed is constant, then centripetal acceleration's magnitude is constant, but centripetal acceleration's direction is always variable. Okay, because here the centripetal acceleration is like this, but when the particle was here, then centripetal acceleration was here. And when the particle was here, again the centripetal acceleration will be like this. So, irrespective of the fact that whether the magnitude of v changes or not, whether the magnitude of centripetal acceleration changes or not, direction will surely change. No, direction will keep on changing. Centripetal towards the center. So, when the particle is here, towards the center it is this. When the particle is here, towards the center it is this. When the particle is here, towards the center it is this. So, direction will definitely vary. And what else you can say? So, overall, the centripetal acceleration vector will surely change. Why, sir? Because magnitude may or may not change, but the direction surely keeps changing, always changing. So, overall vector will also keep changing. I hope the idea is clear to you. Okay. One more time. Let us take a quick recap. I'll give you a quick recap. Before that, you can take a screenshot. I have written a lot. You can take a screenshot, then I'll give you a quick recap. Just a moment. Let me align it a bit more proper way. And all right. Yeah, I think that's cool now. You can take a screenshot here. All right. I hope you have taken the screenshot. Now let us start. I can see in the comment section now, you're talking a lot, and you're talking a lot, especially in Telugu too. So I am unable to understand what you have written. But let us start the question answer session once. What do you mean by dynamics? There is a lot written on board. I have said a lot. Before talking about the special cases involved one by one, let me ask you a few things. Anyone who will express the meaning of the heading, what do you mean by dynamics? Come on, go on. Answer me. Dynamics. Okay. Dynamics means basically in kinematics, we talk about the motion. In dynamics, we talk about the reasons to create the motion, reasons which result into motion. For example, why a body at rest will start moving, or why a body will change its state of motion. The reason is only one, that it is acted upon by some forces. So dynamics of circular motion mein majorly we are going to talk about the forces involved in the circular motion, or you can say the accelerations exhibited by a particle when the particle is in circular motion, accelerations of a particle. Okay. So how many accelerations do we have? There are three types of acceleration. Whenever you do a circular motion question, there are three types of acceleration. Centripetal acceleration or radial or normal means the same. Its responsibility is to change the direction. It will be always there as far as circular motion is concerned. Another one is tangential acceleration. It may or may not be there. Its responsibility is to change the speed. And another one is the net acceleration, which is the resultant of two. How do you take the resultant of two? These two are independent of each other. They are perpendicular to each other. And hence the resultant of two perpendicular vector is under root of this square plus this square. Okay, where their individual formula involved are like this. And how to take about the how to talk about the direction, how to take up the direction is phi will be angle with the any one, suppose velocity vector. Phi is phi is the phi is angle between net acceleration vector and net velocity vector. This net velocity vector is always tangential, naturally here, always tangential. Okay. In fact, now you can take a fresh screenshot. The notes will be available in the Telegram group here. And the way we are studying all this, if you want to learn any other topic taught by me, then on YouTube you can directly write the name of the topic, this by Abhilash Jha Sir Physics. My name is Abhilash, so you can just write down the topic name. Suppose you want to study rolling motion, a very important question, a very interesting question. It was a very basic but a very interesting question of rolling motion also came in NEET 2024. So if you want to study rolling motion, then you can write rolling motion by Abhilash Jha Sir Physics. You will have a lot of videos from there you can learn, right? So any other topic of physics you want to learn, you can do it like that. So what else? So this is the way you calculate the net acceleration and the angle between the net acceleration and net velocity vector. Another theoretical question which generally common question from circular motion is, if it is a uniform circular motion, means speed of rotation is constant, then the centripetal acceleration will be a constant vector or a variable vector. So if speed is constant, centripetal acceleration's magnitude is constant, but since direction will always be variable, overall acceleration, centripetal acceleration vector will be surely variable. Okay, this is a particular question attached to the topic of centripetal acceleration only. Okay, chaliye. Let's talk further. I hope you have taken a fresh screenshot of this. Let me take you to another, like different cases of circular motion, suppose I talk about case 1. You remember the angle, right? The angle phi, the angle between the centripetal acceleration vector and the angle between the net acceleration and net velocity. See, I have told you angle between net acceleration and net velocity. Phi belongs to 0 to 90 degrees. Phi belongs to 0 to 90 degrees. 0 degrees to 90 degrees. You know, this bracket means the extreme points are included. This bracket means the extreme points are not included. So I am taking the curved bracket, extreme points are not included. So you will say that is acute angle. Okay. My case 2 for circular motion will be pi is equal to 90 degree exactly. That is, you will say right angle. Okay. And case 3, you will say phi belongs to 90 degrees to 180 degrees. 90 degrees to 180 degrees. That is, you will say obtuse angle. obtuse angle. Okay, I'll show all the cases possible. When I say I'll show you all the cases possible, it is also indirectly mentioning that the angle 0, if you notice 90 degree I didn't include here, but I have included it here. 90 degree I didn't include here because it was already talked about like in detail in case 2. Okay, but 180 degrees and 0 degrees, 180 degrees and 0 degrees, I am not at all talking about. Neither I am talking about 0 degrees here, nor I am talking about 180 degrees here. Why, sir? Why not it is possible? Why not it is possible? Because in circular motion, if a particle moves in a circle, its velocity is like this, its centripetal acceleration is always there. This is always there. This is always there. This is always there. How the angle can be 0 degrees? I mean, if the tangential acceleration supports here, its resultant will come here. This is acute angle. If the tangential acceleration is here, by parallelogram law, its resultant is here, and you can say this is obtuse angle. I'll show these in one by one in all the detailed diagram. But acute angle can be acute but never 0. Similarly, obtuse angle can be obtuse but never 180, because sir, for 0 and 180, there should not be any perpendicular component. For 0 and 180 degree, there should not be any perpendicular component, but perpendicular component of centripetal acceleration must be present. Perpendicular component of centripetal acceleration must be present. So it was a very nice question which was available in Shri Chaitanya grant test paper in the last year, like 2024, for this year NEET exam. We take here a lot of tests, a lot of quiz for the students, which definitely contributes in the top ranks which we produce from this campus every year. So this year we have also introduced a very cute question, I would say. The cute question from circular motion was that is it possible to have any angle? Is it possible to have any angle between the velocity vector and acceleration vector? So the answer was no, it is not possible to have any angle. Why, sir? You are talking about acute, you are talking about right, you are talking about obtuse. Then if you are talking about all the possibilities, why it is not possible to have any angle? Because if you notice, 0 degrees and 180 degrees are not possible. 0 degrees and 180 degrees are not possible, sir, because for 0 degree and 180 degree, for parallel and anti-parallel, the perpendicular component should be 0, but centripetal acceleration in circular motion can never be 0. Okay? I hope the logic is clear to you. Let me take up the diagram one by one, then you will understand it much better. Suppose I talk about the first one, that is acute angle, means the particle, this is the circular path, my particle is somewhere here, this is the P particle, it is having this Vp velocity direction, and suppose this Vp keeps on increasing. So naturally the tangential acceleration will be directed like this, and you will say this is the center about which it is moving in the clockwise sense, that's the radius. So now I will say since this Vp keeps on increasing, so naturally the tangential acceleration will be supportive. The tangential acceleration will be supportive, then only speed keeps on increasing. The centripetal acceleration is always towards the center. And since speed keeps on increasing, the centripetal acceleration v square by r, that will also keep on increasing. And hence the resultant of these two will be somewhere here by parallelogram law, A net. And if you see one of the component is there, another component is AC here. This one of the components keeps on increasing. So definitely the net acceleration will keep on increasing. And this angle is suppose phi. Diagrammatically you can see that phi will be, phi is basically the angle between the net acceleration vector and net velocity vector. Net acceleration vector and net velocity vector. This is the situation. Okay, diagrammatically. Second thing, if you see, suppose my particle is moving like this, at any p point, the particle's velocity is shown like this, Vp, and you will say this is Vp vector and this is C, this is rotating in the clockwise sense suppose. Now I am saying this right angle, the angle between the net velocity vector and net acceleration vector is right angle. So it is possible only if the net acceleration is here. I mean this is AC always, and you are calling it as net acceleration. So net acceleration generally is the resultant of centripetal acceleration and centripetal acceleration and tangential acceleration. But if you say net acceleration is only equal to centripetal, means here the tangential acceleration is not there. Here the tangential acceleration has to be 0. Tangential acceleration is not available to you. So if tangential acceleration is not available to you, then your velocity vector magnitude, your velocity vector's magnitude is constant. I mean, I'll just represent the speed. So here speed keeps on increasing. Here speed is constant. Speed, I have erased the direction. I'm just talking about the magnitude. Here speed is constant. So for constant speed, I mean, this is also called as the special case of uniform circular motion. Uniform circular motion. It is a special case of uniform circular. Okay. So in uniform circular motion, the speed is constant, but the acceleration is still available. Which type of acceleration is available? Which doesn't change the speed, but it keeps on changing the direction. It always keeps on changing the direction. Okay. And then we talk about case 3. Case 3, what is happening here? I will say there is this particle P. There is this particle P at any point of time. Let us say that it is having a Vp speed directed forward. And here is this center C, radius R, and the particle is moving in a clockwise sense. I have taken the same situation to differentiate between all. Then I will say here what will happen. If there is an obtuse angle, one is the centripetal acceleration, which will always be there. Okay. And for obtuse angle, the tangential acceleration must be here in the opposite direction, such that the resultant A net is here, and the angle between net velocity and net acceleration is this phi, which is obtuse. And since it is in the backward direction, the speed will keep on, since it is opposing. Here in the first case, the tangential acceleration was supporting. Now it is opposing. And if it is opposing, the speed will keep on reducing. And if speed will keep on reducing, the centripetal acceleration V square by R will also keep on decreasing, reducing. Okay. So this is another situation in which it will keep on reducing. And hence all the things are clear to you. Increasing speed circular motion, decreasing speed circular motion, uniform speed circular motion, hence that is called as uniform circular motion. But acceleration is variable. Overall, acceleration is variable in all the cases. Overall, acceleration vector, all types are variable in all the cases. Or let me talk about only the net acceleration is variable in all the cases. And phi is equal to 0 degrees or 180 degrees is not possible between v vector and a vector, net velocity vector and net acceleration vector. I hope that is clear to you. Okay. Now you can safely take the screenshot. The basic things which we study, the basic NEET type of problems which generally come, all the things we have already talked about. Please take a screenshot. All right. I hope you have understood all the things we have learned today. So our next interaction will be like whenever we meet next regarding the circular motion, In this program, I'll keep on taking the fundamental things and the things which where generally aspirants tend to make some mistake. We can improve upon that. So the major trouble with circular motion is there is a slight confusion between centripetal and centrifugal in everyone's head. And there is a slight confusion between the types of acceleration, how do they vary, the angle between the acceleration vector and velocity vector in case of circular motion. So today I have addressed the first type of confusion, that is the type of acceleration, why do they come, what do they do, what is the angle between them, what are the cases possible. Another time, another day, whenever we will be meeting regarding the circular motion, we will be addressing the another confusion, that is the centripetal and centrifugal forces. Okay, why do they come, when are they considered, and what is the purpose of those forces in our daily life and all those things. I hope you have liked the session. Don't forget to like, share and subscribe it, and share it to majority of your friends so that everyone can learn sitting back at home. Okay. All the best. Keep working hard. Bye bye.
Good morning, everybody. Good morning. How many of you are there in the class? Please send a message in the chat, then we'll start. I'll be waiting for the message for first 5 minutes. First 5 minutes, I'll just wait for the message. Murli Mohan, good morning. One person. Murli Mohan, which standard are you in? Which class are you in? Are you in 11th? Are you in 12th? Or are you a long-term student? Gayatri. Okay, Gayatri. Gayatri, are you in 11th, 12th or long-term? 11th. Okay. Okay, bache. Then according to 11th standard, I will teach. Only if you are there, still it is fine. Someone is there to talk to me. You keep talking in between so that we'll have an interactive class. If possible, Gayatri, you can bring 1 or 2 friends of yours. Do you know anyone who you can bring to the class? Or we will continue like this only. Okay. All right. Gayatri, where are you from? Which city are you from? Pillar. Okay. All right, Gayatri. So for you, I am taking a personal class. So you have to be very, you are very lucky that only one person in the class. If anybody else is there, because there was a gap of 30 minutes in between, maybe people have exited. They might come back in some time. So Gayatri, today we are going to talk about how to find the structure of any covalent compound. Lewis dot structure we'll talk about. Okay, so my name is Anirudh. Because of my shoulder injury, I will not be able to write on the top of the board. I'll be writing only at the bottom part. Okay. My name is Anirudh and I am a chemistry senior lecturer or your mentor at Shri Chaitanya Gosala. Okay. Today, the topic that we have chosen for this video is Lewis dot structure. Gayatri, you might have drawn some Lewis dot structures in your 10th standard. If yes, please mention a yes in the chat box. If you have drawn Lewis dot structures, please mention a yes. All of you, those who have drawn few Lewis dot structures or you have seen Lewis dot structures in your life, please put a yes. Then we are going to start. I will give you a very easy trick today of how to draw Lewis dot structures without imagining anything. Without imagining anything, we'll be seeing that. Okay, so I'm starting here. Those of you who are there, please listen carefully. So what Lewis says is, some points are there we should mention. First point is that Lewis tells you that whenever you write the symbol of any element, you show the valence electrons as dots. So valence electrons of the atom are represented as dots, or you can also use star around the symbol. Okay, anyone belonging to group 1 has 1 valence electron, so I can show hydrogen like this. I can show lithium like this. Okay. Anyone from group 2, beryllium, has 2 valence electrons, so I can show it like this. Anybody from group 3 like boron, like aluminium, 3 valence electron, I can show it like this. Aluminium also can be shown like this. Anybody from group 14 or group 4, which is carbon, can be shown like this. All of you have an idea about this. If you are there in the lecture, please write a yes or please write idea, that you have an idea of how to show the valence electron. Nitrogen from group 5 or group 15 will have 5 valence electron. I can show it like this. Oxygen family group 16, I can show 6 electrons, something like this. It's your wish how you want to show. Fluorine group 17, so 7 valence electron like this. Neon, argon, krypton, all the noble gases have 8 around their valence shell. Okay. All right. Next thing is, after you have shown the valence electrons, next thing is we are going to follow something called as Lewis octet rule to draw the structure of compounds. Okay. Second thing is follow Lewis octet rule to draw the Lewis dot structures. Now, what is octet rule? What is octet rule? Octet rule is nothing but Lewis thought that in order to become stable, every atom would want to behave like a noble gas, because noble gases were very stable, they were not reacting with anyone. So Lewis thought that everybody wants to become like a noble gas. So if I am, let's say, chlorine, chlorine has 7 electrons around it, something like this. 7 electrons around it, something like this. 1, 2, 3, 4, 5, 6 and 7. Chlorine wants to mimic neon, because chlorine wants to become like a noble gas, to become stable. So chlorine requires 1 more electron to come to it so that it can become stable. Okay, that is Lewis octet rule. That in order to gain stability, the atom will either gain electron or will lose electron, or sometimes may share also. So 2 things chlorine can do. Chlorine can do 2 things. It can either gain an electron, like reacting with sodium. You know, when sodium reacts with chlorine, what will happen? Chlorine has 1 electron outside its octet, so it is 2, 8, 1. Chlorine is 2, 8, 7, if you remember the electronic configuration. Now, what they should do is, sodium, if it wants to reach to octet, it wants to lose its electron. So this electron will be given to chlorine. Sodium will become Na positive, which will become 2, 8. And chlorine will become Cl negative, which is 2, 8, 8. And this is how they make the ionic bond. Because 2 ions are formed, so chlorine gets the 8th electron. Both of them are very happy that we have octet rule completed. So here sodium has become like neon, 2, 8, whereas chlorine has become like argon, 2, 8, 8. So like this, they have formed the bond by complete gain and loss of electron. So I can say here, sodium is becoming stable by losing electron, chlorine is becoming stable by gaining the electron. Okay. Other words, they can share also. Let's say if there is a hydrogen and there is chlorine. Hydrogen and there is chlorine. In this particular case, what happens is, as you know, hydrogen chloride exists as HCl gas. So in this case, chlorine does not gain an electron. Instead, because hydrogen is not a metal, hydrogen is a non-metal. Okay, and non-metals do not just lose their electron like that. So in this case, they will share electron. Here they are exchanging electron. So this is complete transfer of electron. Whenever there is complete transfer of electron, there is going to be formation of ionic bond. So ionic bond always exists between a metal and a non-metal. Calcium chloride, Padma, good morning princess. There were very less people, so I started the class. Those who have joined now, you can please start the class from the beginning. Okay, just go back and start the class. I will be telling you a very nice trick to draw Lewis dot structures. Can you tell me, Suprita and Padma, can you tell me which class you guys are in? Are you in 11th? Are you in 12th? Or are you a long-term student? Gaming with Dinesh. Okay. And have you all drawn Lewis structures before? Princess 11th. Okay. Suprita 11th. Padma is also in 11th. Dinesh, what about you? All right. So according to 11th only I'm teaching. I'm teaching very much basics. 12th passed. Rohit. Okay. Then Rohit, you'll be able to understand a little better. 12th passed. All right. Okay, guys. So we were talking about Lewis dot structures. Few points that Lewis told us, that whenever you are trying to draw a structure of a compound by my theory, which is Lewis theory, show the symbol followed by number of dots equal to the valence electron. All of you know the number of valence electron. Then after that, follow the Lewis octet rule to draw the Lewis dot structure. In case there is a metal and a non-metal, there will be an ionic bond. Ionic bond is formed by complete transfer of electron. You don't have to write the notes right now. Once we start with the structures, you can start with the notes. Okay, complete transfer of electron gives you ionic bond. And here, if both are non-metal, then they will share their electron. Hydrogen say, I will share my electron with chlorine. That means you can keep my electron, at the same time I will also be able to keep your electron. So HCl will form like this by sharing of electron. This electron of hydrogen and this electron of chlorine, this will be shared between both of them like this. And this becomes a covalent bond. This becomes a covalent bond. By sharing of electrons. By sharing of electrons. Alright guys, now we'll be starting with the Lewis dot structures. First few Lewis dot structures, whenever we talk about Lewis dot structures, we are talking about covalent compounds only. For ionic compound, there is no Lewis dot structure. Like for HCl, this is the structure that we have drawn here. Okay. So in this case, you can also draw it like this, saying that now chlorine also has 8 electrons, so chlorine is happy. Hydrogen has 2 electrons around it, so hydrogen is also happy. For everyone else, we call it octet rule. But for hydrogen, we call it duplet rule. Because hydrogen wants to mimic, okay Pravina, hydrogen wants to mimic the noble gas which is helium. Hydrogen cannot keep 8 electrons, it does not have that much space. So hydrogen wants to get 2 electron, everyone else wants to get 8 electron in their octet. This is how octet rule will work. Now we'll start, you can also start writing. Drawing the Lewis dot structures of simple covalent compounds. First, we will draw it by imagination. And after some time, I will give you a very nice and simple trick by which you can draw any difficult compound as well. Okay. By the end of the class, you'll be able to draw things like HNO3, H2SO4, H3PO4, HClO4. All those structures you'll be able to draw by the end of the class. Drawing the Lewis dot structure of some simple covalent compounds, like simplest one I'm taking. Let's say we talk about first example, Cl2. Cl2. So Lewis is thinking how Cl2 exists. So Lewis thought there are 2 chlorines. I'll make 1 chlorine here, 1 chlorine here. Chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. This one also has 1, 2, 3, 4, 5, 6, 7. Left chlorine says, in order to become stable, I need one extra electron. So I will share one with you. In return, you also share one with me, so that both of us become happy. So now this chlorine is happy because the number of electrons which are there in this green color circle are 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. This chlorine is also happy because in the blue circle also 8 electrons are there. So both chlorines are happy and they have in sharing 2 electrons. 2 electrons in sharing means 1 bond. All of you know this. So it is a chlorine, single bond chlorine. There are 1, 2, 3, 4, 5, 6. 6 unshared electrons on this chlorine, 6 unshared electrons on this chlorine, like this. Okay. Rohit Kumbar, it is a program named for the long-term students. Okay. All right. Next one. After Cl2, let us go for a little difficult one like CH4, methane. Methane. So in the Lewis structure, always keep the atom which is less in number in the middle, atoms which are more in number as surrounding. So in CH4, carbon is less in number, so I'll keep carbon in the middle, hydrogens on the surrounding. Okay. I am showing the lone pairs of carbon with the pink color, and for hydrogen I will show it with some other color, yellow color. Carbon has 4 unpaired, 4 valence electron. 1, 2, 3, 4. This is our carbon. Okay. Carbon says I have 4, I need 4 more to become stable. No problem. Hydrogen, each hydrogen has 1 electron. I am showing it by X. 1, 1, 1, 1. So each hydrogen is talking to carbon saying that I have already 1 electron. I want 1 from you. So carbon says, okay, I'll share 1 with you. So this carbon shares 1 with this hydrogen, shares 1 with this hydrogen, shares 1 with this hydrogen, shares 1 with this hydrogen. Every hydrogen say, now I am happy. Carbon says, I am also very, very happy because I also got 8 electrons around me. Carbon had 4, it shared 1, 1 from these 4 people and became stable by having 8 electrons. So carbon has complete octet here, hydrogen has complete duplet here. CH4 looks like this. 2 electrons are in sharing here, so 1 bond here. 2 electrons in sharing here, 1 bond here, 1 bond here, 1 bond here. CH4. Is it clear to everybody? Can you tell yes or no if anyone is actually studying? Do you all know how to draw the structure of simple compounds like CH4, Cl2? Clear? Okay, Vijay. All right. Now I will give you the trick to draw these. Are you all ready for a trick? Are you all ready for a trick? Yes. Okay. The trick is known as TVSU trick. TVSU. Okay. We'll call it TVSU trick, which will help you to find structure of any difficult molecule as well. I will call it TVSU trick. Here, these are the 4 numbers that we have to find. Value of T, value of V, S and U. T means total electrons. How do you find total electrons? T means total electrons required to complete all the octets and duplets. That means how many electrons are required by a molecule to become happy. So total electrons will be nothing but number of atoms into 8, because each atom will say I require 8 electrons to become happy. First you will see many examples, then automatically you will find the T value. How many atoms are there into 8 plus how many hydrogens are there into 2. Hydrogen will say, to become happy, I don't need 8 electrons. I need only 2 electrons because I follow duplet rule. Other people follow the octet rule. So how many atoms into 8? Atoms except hydrogen. Atoms except hydrogen into 8 plus how many hydrogens into 2. Okay. V means nothing but valence electron. All of you know how to find the valence electron. It is nothing but sum of all the valence electrons. S means shared electrons. This is important. Shared electrons, let's say we'll show it by dots here. It is nothing but T minus V. Remember it, T minus V. So first number minus second number, we get the shared electrons. U means unshared electrons. I will show it by star. It will be second number minus third number, V minus S. Okay, so finally we have to reach to S and U, and you can draw any structure. I'll show you a few examples. Finding the TVSU and then drawing the structure. All of you can quickly see 3 examples over here. Then you can write. I'll give you time to write. I'll give you time to write. All of you, please see here 3 examples that I'm showing you. All of you, please see here. Drawing the structure using TVSU. First example, I am taking ammonia. Second example, I will take water, H2O. Third example, I will take PCl3. Fourth example, I will take CO2. These are the 4 structures I am going to show you how to draw. All right. First thing is TVSU. All of you please see here carefully. TVSU. T means how many electrons do you require to become stable. Here there is 1 nitrogen. Nitrogen says I require 8 electrons to be happy. 3 hydrogens are there. They will say I require 2 electrons to be happy. Okay. I mean, we are checking how many total electrons are required to fulfill everyone's need. Nitrogen says my need is 8 electrons. Hydrogen says my need is 2 electrons. So nitrogens need 8. 3 hydrogens need 2, 2, 2. 8 plus 6, 14. T value is 14. Now V, valence electron. We know nitrogen has 5 valence electron and each hydrogen has 1 valence electron. 5 plus 3, 8. So V value is 8. V value is 8. S is nothing but first number minus second number. 14 minus 8 means 6 sharing electrons will have to keep. I am showing sharing electrons as dot. 6 dots will be there. 14 minus 8. Next value will be V minus 8. S. 8 minus 6, which is 2 unshared electron will be there. This is how you find the TVSU. Very simple. Again, I am saying those who didn't get it for the first time, it's simple one. T means how many electrons are required for everyone to be happy. To be happy, everyone would require 8 electron. Hydrogen would require 2 electron. Ammonia has 1 other person, 3 hydrogen person. 1 ammonia, 1 nitrogen require 8, 3 hydrogen require 2, 2, 2, 14. Valence electron, you know. T minus V, S. V minus S, U. 6 dots, 2 stars I will make. 6 dots, 2 stars. So this is how ammonia would look like. I will keep the nitrogen in the middle because nitrogen is less in number. 3 hydrogens on the side. No need to imagine anything. Just put the S and U, shared electrons and unshared electrons. Shared electrons are 6. So start giving them shared electrons. You 2 people share 1 pair. I mean 2 electrons you share, 2 electrons you share, 2 electrons you share. 6 electrons are done. 6 electrons are done. Okay. Shared electrons obviously will go in between the people. No. If nitrogen is attached with hydrogen, you give them 1 pair of shared electron, 1 pair of shared electron, 1 pair of shared. All 6 sharing electrons are done. Now ask everyone, are you happy? Nitrogen says, I am though not happy because I don't still have 8. I don't have 8. I have only 6. Hydrogen says, I am happy. Hydrogen says I am happy. Hydrogen says I am happy. Anyone who is happy, put them into the circle. Now come to unshared electron. Hydrogen said I am so happy, so don't give me any unshared electron. So obviously the unshared electron will only go to nitrogen. So I will put the unshared electron to nitrogen, and then we ask nitrogen, are you happy? Nitrogen says yes, I am completely happy. I have 8 electrons. I will be showing you examples. Don't worry, slowly it will come. First, give sharing electrons. Once you have given sharing electrons, ask those people, are you happy? If someone is happy, put them in a circle. If they are not happy, start giving them unshared. Start giving them unshared. So this becomes the structure of ammonia. Nitrogen singly bonded to 3 hydrogens. N, single bond H, single bond H, single bond H, and there is a unshared pair on nitrogen. I can show it like this. This is ammonia. I am showing H2O after this. All of you please look at it. Then you can write it down. TVSU. All of you please see here. It is a very easy and useful trick. Little bit pain is there in my shoulder, so I can't lift my hand. So that's why I'll just show the bottom part as well. TVSU. T. 2 hydrogen will say we require 2 electron. 1 oxygen will say I require 8 electron. 8 for oxygen to become happy. 8 plus 4, 12. Total electrons are 12 required. Valence electron. Valence electron, hydrogen has 1. So 2 hydrogens have 1, 1. 1 oxygen has 6. 6 plus 2, 8. 12 minus 8, 4. 8 minus 4, 4. 4 dots I have to keep. 4 stars I have to keep. 4 dots, 4 star. Let us start. In H2O, because oxygen is less in number, so I'll keep oxygen in the middle. I'll keep oxygen in the middle. Oxygen, you come to the middle. Hydrogens, you go on the sides. Now I need to give shared pairs. Means I have to keep 4 dots. I have to keep 4 dots. Let us start giving dots. You take 1 bond. You also take 1 bond. 4 dots are done. No more dots are available. Hydrogen, are you happy? Hydrogen says yes, I am very happy. Circle the hydrogen. Circle the hydrogen. Oxygen, are you happy? Oxygen says no, I am not happy. I have only 4 electrons. That means unshared I will only give to oxygen. Start giving unshared electrons. 4 are there. 1, 2, 3, 4. Oxygen says I am very happy now. Oxygen says I am very happy now. 8 electrons. So finally structure becomes oxygen singly bonded with this hydrogen, singly bonded with this hydrogen, 1 lone pair, 1 more lone pair, 2 lone pairs on the oxygen. Like this. Just find TVSU, find TVSU, draw the symbol of the element less in number in middle, draw the symbol of elements more in number on the sides, start giving shared electrons. Once you have given all the shared electrons, circle the person who has completed the octet, and the ones you have not circled, start giving them lone pairs or unshared electrons. I hope it makes sense. One more I am showing. CO2. PCl5 will be your homework. PCl5 will be your homework. This one, CO2 also I am showing you. All of you can look at this. TVSU. Total there are 3 people, none of them is hydrogen. So nobody is asking for 2 electrons. All these 3 people, carbon and 2 oxygens, will ask for 8 electrons. So 24 becomes T. 24 becomes T. Valence. Carbon has 4 valence electrons, as you know, And oxygen has 6 valence electrons. So 2 oxygens will have 12. 4 plus 12, 16. 16. S, 24 minus 16. 8 dots I will have to keep. 16 minus 8. 8 stars I will have to keep. Okay. 8 dots, 8 stars. All right. Let us draw. Who will be coming to the middle? Carbon will be coming to the middle. Oxygens will be coming to the sides because carbon is less in number. Oxygens are more in number. Start giving the sharing. 8 electrons I have to put in sharing. You take one bond, you take one bond. Okay. But I have given only 4 till now. Then you take another bond. You take another bond. All 8 I have shared now. Ask carbon, are you happy? Carbon says, I am the happiest. I have complete octet. I am very happy. There are 8 electrons around me. I don't require any unshared electrons. I have completed my octet. Okay. I don't require any unshared electrons. I have completed my octet. You give stars only to oxygen. I don't need any star. Now 8 stars I have to give. Give to this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen, are you happy? Yes, I am very happy. So this oxygen has completed its octet. Which color I should keep? And this oxygen has also completed its octet. All of them are very, very happy. Carbon with 8, oxygen also with 8. So it is, now there are 4 electrons in sharing, means 2 bonds. Here also 4 electrons in sharing means 2 bonds. So C double bond O, C double bond O. This oxygen has 2 lone pairs. This oxygen also has 2 lone pairs. Hi Prabhavati. Please tell those of you who are there in the class, is it clear to everyone how to draw the Lewis dot structure? Then I will give you some difficult ones as well. What is this torture? You're getting tortured, you can leave the class. Then it's okay. Don't hide these comments. Is it clear? Clear. Okay. Next we can go for another structure now. I can give you for homework at least 10 to 12 structures. Now just one more I am going to show where and all coordinate bond will come and negative positive charges will come. So next structure we are going to go for is, I am going for a negatively charged structure, carbonate, CO3 2 negative. See, whenever a charge comes, that charge actually means nothing but some electrons are added or removed. If there is a negative charge, means electrons are added into the neutral species. If it is a positive charge, electrons are removed. So whenever there is a plus minus, only V value will change accordingly. Valence value, valence electrons value. T and other things will not be dependent on that. So carbonate, I am finding TVSU. I am talking to the molecule, asking it, how many electrons do you require to be happy? Okay. Can you tell me how many molecules are required to be happy by carbonate? Anybody can comment? How many will be the T value? What will be the T value? How many electrons are required by carbonate to become happy? Carbon is there, 3 oxygens are there. So total there are 4 people. 4 people want to complete their octet. 4 people wanting to complete their octet. Anybody? Nobody. Very good. 4 times 8, 32 electrons are required. Okay. Valence electron. One carbon is there, so carbon has 4 electrons in the valence shell. 3 oxygens, everyone having 6. 2 negative charge means extra 2 electrons are there in the valence shell. So CO3 would have been this much. CO3 2 negative means 2 extra electron. When you sum them, 4 plus 18, 22, 22 plus 2, 24. S means T minus V, as I told, 32 minus 24, which is 8 electrons are going into sharing. I'll show it by dots. V minus S, 24 minus 8, 16 are going to be present as lone pairs. Okay, lone electrons or unshared electrons. Okay, 8 and 16. 8 and 16. So we'll start by drawing the structure, keeping the carbon in the middle because carbon is less in number, oxygens on the surrounding 1, 2, 3. Start by giving shared electrons. 8 I have to give. You take 2, you take 2, you take 2. So 6 I have given, but I have to give 8. So these two people will keep 2 more. So I have given double bond on the top carbon oxygen and single bond at the bottom carbon oxygen. Carbon says, I am happy, I don't need any more electrons because I have completed my octet. So I'll just keep the carbon in the circle. Carbon does not require any stars, it has completed its electron. Then oxygen. For oxygen only we have to put the unshared electrons. 16 are there. I'll start by giving a pair 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This oxygen says I don't require anything else because my octet is also done. 12 I have given till now. 12. 13, 14. This oxygen says I am also done. 15, 16. This oxygen is also happy now. Okay. So this is how the structure looks like. I have completed all the octets. If you tried to go by imagination, it would have become a difficult question. But now, because I have given you the trick, you can do it by this method. So it is a carbon doubly bonded with the top oxygen, singly bonded with these two oxygen. Okay, so this becomes the structure. Now, one thing to always keep in mind, oxygen, as you know, is a bivalent species. Means oxygen, whenever it attaches, it must attach by 2 bonds to be neutral. Otherwise, it is not neutral. So, whenever oxygen is attached by a single bond, it will always have a negative charge, like hydroxide, you know, OH negative. OH negative. So, in hydroxide, O gets a negative charge. Same way, whenever oxygen attaches by a single bond, it must get a negative charge. So, carbonate has 2 negative charges. 1 negative will be present over here. 1 negative will be present over here. Okay. So, this oxygen will be 1 negative. This oxygen will be 1 negative. This is how you can draw the structure of carbonate. Lone pairs I am showing here. 2 lone pairs are present on this oxygen. 3 lone pairs are present on these oxygens. Okay. So, that is how you draw the Lewis dot structures of these compounds. Okay. You can draw them and then wait for the next class to start. Thank you. Bye bye.
Good morning, students. In our botany session, I'm going to handle our today's session, myself Rohini Gupta, one of the botany faculty here. So we are taking one topic from the chapter Morphology of Flowering Plants. It is displayed on the board right now. First of all, before starting our session, please put your thumbs up if voice is audible and the clarity of board is there. Please do participate whatever I am asking you so that I get the clarity of the thing. This is the meaning of a live session, that you should keep on updating your lecturer even. Put your thumbs up for clarity of voice and the board clarity. I'm not getting your response. If there is no thumbs up or something like that, I think so I am clear. No issues from your side. So right now I am starting with my topic. I am going to take the topic, the root, under the chapter Morphology of Flowering Plants. See, before getting into some of the questions in our important chapters, see, you should know why we are taking that in our small period of this live session. In 2024, in the last question paper, you find the 3-4 questions came from the chapter Morphology of Flowering Plants. Until and unless you are not understanding the concept, okay, I'm getting the response now. All are giving the thumbs up, means I'm audible to you. So I'm coming back on the importance of this chapter right now. That is the Morphology of Flowering Plant. 2024, you found the 3 questions main over there. One is the match the column based on androecium part, means from the flower. One is a mixed type of match the column. They have given like a type of estivation you need to match, or even the type of fruit you have to match. That is a mixed type of the match the column. And one more diagram based came based on the monocot seed. They have asked you the labeling over there. So these were the main question in the last 2024, means your NEET exam. So this chapter sometimes is having big weightage as well. They can ask you more than this very number of questions. So I'm starting with the basic thing right now, that is the root. To start with this topic, let me to tell you one thing, that in the botany you should know the meaning of the terms. We are dealing here with the topic morphology, right? Morphology is the common term to plants as well as to animals. Here the word morpho stands with the form and the structures, means form and the features of plants. Ology means to study. Study of form or features, but here in this chapter we are discussing about the external morphology. Morphology can be of 2 types, external as well as internal. If I am talking about internal, means I am talking about your next chapter, anatomy of flowering plants. Right now in our today's session, we will discuss only about the external morphology. Under external morphology, what we are going to take, that is the organ root over here, right? So I am starting with that topic, the roots. Now let's talk about the roots are having what type of features. What are the features of the roots? The root as an organ, if you talk about the plant, starting from the cell as an organization, they form tissues. Tissues form organs. Organs are now in plants, they are not forming organ system. They are forming organism now. Organ system level you will find in the kingdom Animalia. The root as an organ we are taking right now in the plants, right? So externally, what are the features that make you to say that this is a root? Very important, they are underground. I am not talking about exceptions here. I am talking about its external features. They are underground. Can I say they will be non-green? Right? And it will be positively geotropic See here the word I am writing tropic. Here the students are making mistake. The word is tropic. The word right now is not trophic. It is not trophic, right? Trophic word is related to food, whereas tropic word relates to movement plus growth. Here the movement of or growth of root is happening towards the earth or towards the ground. That is geotropic growth, or you can say growth plus movement, right? So be careful about the terminology. I know that this is going to be, seems to be very easy topic, but if you don't know the terminology, in this type of trap, they can trap you, right? So do patient in listening the things and keeping in your mind. Clear? So here I am talking about they are positively geotropic, but they are negatively phototropic, right? They are growing opposite to the light, right? That's why they are negatively phototropic, right? So terms are very important, very, very important. Clear? So here roots, we are taking underground, non-green, positively geotropic, negatively phototropic. When you are sowing a seed in the ground, giving them proper environment, the thing what is coming out, that is the shoot system in a seedling, which is growing down is a root system. But root system is originating from which part of the seed? Can I say these roots originate from the, its origin is from the radical part, right? Its origin is from the radical part. R for radical, R for the root, right? So that will be its radical part is going to be its origin. Fine. Now coming to the next thing, if I compare the root with the stem, you will find on the stem you will find nodes and internodes. Suppose this is a stem and there you have the leaves. Where the leaves are there, you call it as node. That node will be the feature of the stem. But in the root, there is absence of nodes and internodes, right? I repeat, what is that nodes and internodes here? If I am taking this for the stem right now, I am talking about the stem because I am comparing this point in context to the stem. This part or the region from where the leaf originate, where I am keeping the lines, such lines are not directly there on some plants. I am keeping that lines. These you call it as nodes. This is what thing? Node. I must say I am marking one node at a time, so I can write it as a node. This is a node part, right? So this is node, this is node. What is in between that? What is this thing? This thing is the internode, right? So node and internodes, node and internodes are the feature of a stem, but absent in case of the roots, right? Exceptions are always there in biology. So if I am taking about the exception here in case of the dahlia, or even if I am taking for the epomia, which is commonly asked, I am taking for epomia, commonly asked. Epomia, exceptionally, it is having the, on the nodes, they are having the buds. Now what is that buds here? This exception I am considering in context to the buds. Now what is bud? This is present on the nodes at the angle of the leaf and of the stem. I repeat this point once again. This is the node part, right? Can you see here leaf will start? Here at this angle there is a presence of buds. Are you getting that? I am not saying the exception of nodes and internodes. I am telling you the exception of the bud here. One more point. Here the buds are absent in case of the roots. but present in case of the stem. But what is an exception to the bud in the root? That will be apomia, will be an exception here, right? So on that grounds, you can differentiate the roots and the stem. Externally, what stem is carrying? Nodes and internodes. On the node, you will find the buds, right? Bud will be present between the internode and this leaf part at the angle of this. This bud is an axillary bud. This axillary bud or this type of bud what I have shown at the node region is the feature of stem, but it is absent in case of the root. So here can I write here? Buds are even absent. But what exception I have given you here? Of epomia, which is having the bud over there. This is an exception, right? And epomia is sometimes they can given in you the options, right? Very common example in the botany, right? So I hope so you get the introduction. What are the roots? What is the origin of the root? Radical part, right? Radical part is giving rise to the root system. Plumule is giving rise to the shoot system, right? And it is the positively geotropic part of the plant. Positively means it is growing towards the earth. Negatively phototropic means it is moving or growing away from the light. Tropic word is there, it is not a trophic word. This is very important thing, you have to correlate with that, right? So these are the journal terms related to the roots. Now coming to the next part, the external morphology when you will see, can you see the position here now? This is under the ground, just now what I have discussed with you. And upper side will be the aerial part which will include flowers, fruit, stem, leaf and constituting the shoot system. Right now we are discussing this root system, and root system comes under vegetative morphology because it is the vegetative part of the plant, right? Whereas the shoot system, it can have both vegetative, or we are dealing here both vegetative as well as reproductive morphology, right? Reproductive morphology here include what thing? Flowers will be there, inflorescence will be there, right? And after the reproduction, flowers form fruits, and inside the fruit seeds are there, right? Enclosed inside the fruit seeds are there, as we are discussing about flowering plants, right? They are having seeds, right? So here we are discussing about the reproductive morphology. In your book they have given for flowers and the inflorescence, right? Now we have to deal with the vegetative morphology. Today's lecture we are taking vegetative morphology, that is based on the root system, right? So this diagram is given in your NCERT book. Please be very much cautious about this. All labeling given, which labeling is for what. NCERT diagram only they will pick, and they will not obviously ask you to draw it. Then even you should know on the labeling side what is given and what is the caption given for that picture or a diagram shown in your book, right? So here just now they have given the external morphology of a flowering plant. Here we are going to take the root system, which is coming under the vegetative morphology part. Now let's talk about the next topic under the root, right? What we are going to take here, that are the types of the root. Types of the root, how many are there right now in front of you? 3 types. One is the taproot, fibrous root, adventitious root. All that 3 diagrams you will find in your NCERT book, right? So what these diagrams are conveying? Let's talk about the first type, taproot. Can I say it is forming a system here? I repeat one more thing, that using the word root system and shoot system, it never means that plant will reach up to the organ system level. Here the word system is normally like a English term, where when system is working in coordinate manner, in scientific manner, that is even a system here. But here the word root system, we never mean to say that they are the reaching up to the organ system level of hierarchy. This is only a system which is performing scientifically and systematically the process of absorption of water and minerals, right? So do remember, plants are showing up to the organ level of organization, then they are forming plant as an organism, right? So under the root system, we are taking the type of roots. First is the taproot, showing the taproot system, fibrous root system, adventitious root system, right? Now let me to talk about the taproot. Taproot is originating basically from where? From the radical part. Radical part will show elongation and create this elongated part. What you call this elongated part as? That is a primary root, right? That primary root is further divided into their branches. It extends and after that it will divide into the branches, right? That branches of various orders, means it can be secondary or further tertiary and furthermore. When you have all these type of thing in a root system, such type you call it as taproot system. Still you have primary root directly coming from the radical part. Branching, rebranching is there of various degrees if it is there. Such type of root you call it as tap root, and that system of that root system you call it as taproot system. And generally this is more common, or you can say this is a feature of the dicots. For example, in case of mustard, right? For example, mustard, dicot feature, they are showing the taproot system. Now what is the second type of root system right now on the board? Fibrous root system, or which type of root is there? That is the fibrous root. Even fibrous root is originating from the radical part, right? Now what is happening? Do listen this point very carefully. I am talking about this fibrous root. In fibrous root, what happened? Suppose this is a ground level. You have sown a seed here, and when it will be sprouting, it will give up the shoot system downside as a root system. Now that root system, suppose upside is the shoot system coming out like that. Initially it give rise to the primary root. Initially it will elongate as a primary root, but gradually this primary root will disappear and you will have a bunch, or you can say tuft of roots coming out from the base of stem. Are you getting that? Later, can I say fibrous root system, later it becomes adventitious root. Why adventitious? Because later this tuft of root is coming out from the base of the stem, right? Initially origin is from radical. That's why fibrous root we are not directly keeping under the adventitious. Initially it originating from the radical part, later gradually that primary root will disappear and tuft means cluster of the hairy type, or I may say the type of root system as a bunch or a tuft will start coming out from the base of the stem. And later at this stage now you can call it as an adventitious root. That's why modification of root, some examples of the monocot even comes under the of fibrous are coming under the adventitious root modifications, right? So let's go on the previous slide now. Here I am talking about this fibrous root. Can you see the tuft or the bunch of root is coming out from the base of their stem? When you pull out the grass, you will find it very clearly, right? So this tuft of root is coming out now from the base of the stem. What is the feature here? This is the feature mainly for the monocots. What is an example here? Just now I said you, like in case of the grasses, right? You will find that. This is the example for the fibrous root system. Now next, what is that? Next is for the adventitious root. Adventitious root from the beginning. By beginning I mean to say that when it originates, this adventitious root originates, or its origin is other than radical. When the origin is other than the radical, then that type of root you call it as adventitious root, right? They don't have origin from the radical at all from the beginning. They are coming from the part other than the radical. See, the adventitious word, when it is used in full chapter, means other than its basic origin. Here we are talking about roots. What is the basic origin? Radical. So if it is originate other than the radical, it become adventitious root over here, right? So what example they have given over there? Like in case of the banyan tree, you are having as in what type of root? Prop roots, right? Even in case of the monstera, you will find that. Some example given in your NCERT book, right? So do remember the diagrams to which category it belongs. If I am marking it as an A, like with the diagram, this is A, this is B, this is C, right? So you must know about A is for, this diagram is for taproot, this is for fibrous root, this is for adventitious root, right? So these are the type of the roots just now we have discussed. Next, after this, let's talk about this regions of the root. Regions means what are that parts of the root where what thing is happening. You will find basically it consists of the three regions. The first, which is present here, that is region of meristematic activity. Second is what? Region of elongation. Third is what? Region of maturation, right? Three regions. Region of meristematic activity, region of elongation, region of maturation. Now what type of question they can ask you from here? For that type of question, first of all you should know this side where the things will be growing, that side will be the apex or the tip of that organ, whereas this one is going to be the base. If I am asking you these regions from apex to the base, then you have to say region of meristematic activity, region of elongation, region of maturation. If I am asking from base to tip or the apex, then region of maturation, region of elongation, region of meristematic activity. This is the first important question you should know based on this diagram, right? Now let's talk about one by one all the three regions. If I am talking about the first one, what is that? Region of meristematic activity, right? Region of meristematic activity, can I say it consists of which type of cells? These consists of meristematic cells, right? And these meristematic cells, what are its features? Can I say these meristematic cells, these are thin walled, these are dividing cells, and they are without vacuoles, right? And this meristematic region, this is few millimeter above the tip. Reason why? Because this is covered by the root cap, right? Which you even call it as a calyptra, right? This root cap is thimble-like. What do you mean by thimble-like? Thimble-like means when you are playing a guitar, you are having some covering so that that string should not damage your finger, right? It should not going to make your finger hurt. To protect your finger, you are wearing that thimble. Same way here, due to growth inside the ground or piercing through the soil, the tender, soft meristematic region can be harmed. To protect it, it is having the cap over there, that you call it as a root cap. And what is the other term for that? Calyptra. It is thimble-like, right? And it is secreting the mucilage. It is parenchymatous. It is made up of parenchymatous cell, secreting the lubricants so that the pathway become very smooth to pierce in through that ground level, or when they are passing through the soil, that particles should not damage the meristematic tissues over there. Getting that? So on that grounds they are having this root cap. Now the root cap is on the apex side or on the base side? It is toward the apex side of the root, the regions of that, right? Now what is happening after the divisions of the cell? Few cell will enter into next region. That region you call it as region of elongation. Can I say now in the region of elongation, the second region, what is that? Region of elongation, as the word is indicating. Obviously, what is happening to the cells? They are becoming elongated, right? Additionally, they are becoming enlarged. How this all happens? By the water, which is putting pressure in their cells and start making the vacuoles. Meristematic cells, I already mentioned you, they don't have vacuole. When vacuolization starts, means when vacuoles start appearing, that will pick up the water and put the pressure on the cells and making the cells elongated and expanded or enlarged, right? So obviously this region is more as compared to this meristematic. Meristematic is hardly on the tip. After that is the region of elongation, right? So can I say meristematic tissue help in the growth of the root by the division of the cells. Elongation helps in the enlargement of the cells. Are getting in this way, it will help in the growth of the roots. Now that cell again, now few of that enter into region of maturation. Now for the region of maturation, have a look right now on this diagram. Can you see here the root hairs will start develop. This is very important point. Can I say root hairs are the feature of the roots? Means these projections are on the roots. Trichomes are there on the stem, that we will discuss in anatomy part. Right now I am discussing with you only about the roots and its external morphology. So you will find in the region of maturation, very important thing, root hairs. And do remember, this is very important but not mentioned in your book, but the words they are using, acropetal, basipetal, that type of thing you should know. Can you see here, the root hair in the diagram have shown on this side, means toward the apex. This is the apex side, this is the base side. Tip side, base side. Can I say towards the tip, they are small in size or in their length, and they will be longer, one toward the base side. If something smaller, or you can say younger one, if it is toward the apex, older one or the longer one is toward the base side, such type of arrangement you call it as acropetal arrangement of the root hair, right? This is not given as line to line in your NCERT, but based on this diagram you should know this type of orientation of the diagram. I repeat, region of maturation, they are having root hairs. What are root hairs? These are small, hairy, tender type of structures which is projecting out from the epidermal cells to make the surface area more for absorption of water and minerals. But how it is going to be arranged? In an acropetal fashion. Acropetal means younger are towards the tip and older one are toward the base side, right? When we will discuss in anatomy the transverse section of the root, we are taking it transverse section from the region of maturation. That's why you will see in their diagram they are showing you root hairs. To show the transverse section of root, we never cut on region of elongation or from region of meristematic, because still they are younger as compared to region of meristematic. Fine. So be careful in the direction through the diagrams what they are showing, or through the line to line they have given in your NCERT book, right? So root hairs, they are mainly for absorption. absorption and even to increase the surface area. Obviously, whose surface area they are increasing? For the absorption of the water and minerals. They are increasing the surface area. Where you will find the root hairs in the region of maturation, right? So it is towards the base side, region of maturation, and region of meristematic activity is toward the apex side, right? So just now we have completed the 3 regions of the root. One I mentioned to you, the region of, first of all we discussed about region of meristem, then we discussed about region of elongation, then we discussed about the region of, third one, what we have mentioned here, region of maturation, right? And what is the main feature over there? Presence of the root hairs, right? And root hairs, these are exogenous in origin. Exogenous means it is an extension of epidermal cell, epidermal cells, right? And root hairs, they are going to be unbranched. They are unbranched and they are unicellular. These 2 words are important, that root hairs, they are unbranched and they are unicellular, right? So this is about the regions of the root. Now coming to the next point, we have to talk about the root modifications. But before getting into root modification, you should know about what is the primary role of the root. Primary means roots are there in plant mainly for what thing? Can I say it is for absorption? Just now I said you, absorption of water and minerals. Second, even it helping in the anchorage, means it is going to make a grip with the soil and making the plant to be there on the ground. That grip is provided by the roots, right? And no doubt PGRs are even given by the or secreted by the root, and they are even storing the food over there. The line what they have given in your NCERT book, storage of food in the root, that they are not always indicating like sweet potato over there or turnip, like that example. Like in chapter now deleted, transportation in plants, there you will find bidirectional flow of the food. When the early spring season is there, upside the leaves shed off, but flowers are about to bloom, they need the food more, but leaves shed off to give, not all, the leaves start shedding at that time to give space to the flower. Then who will overcome that demand of food? Then the roots will start supplying back the food to that flowers which are going to bloom. So in the phloem, the bidirectional flow of food can be there. So they are talking about that storage of food over there, right? So in the one line in your NCERT, they have mentioned all that 4 things, but do remember absorption is the first of one. And even the anchorage means to fix or to grip with the ground. Even PGRs, plant growth regulators, hormones, even they are giving, and even they are storing the food, right? So these are the prime things. But now what is modification? When the roots will change its structure or their any shape and perform the function other than the primary function, that you call it as a root modification. I repeat, they change in their structure and the shape and perform function other than the primary function, that you call it as a root modification, right? And I already discussed what are the primary function of the root. Now let's talk about the types of the root. Types of root modifications, I want to say. Types of root modification. First is the taproot modification. Second is the adventitious root modifications. I am not taking the fibrous root modification, because at last when it starts showing modification, it enters into adventitious state. If you have listened my lecture from the beginning, I already mentioned how fibrous, later you call it as adventitious type of the root system, right? So later it get modified into that. Clear? So coming to this point, that root modification, here I am taking the taproot modifications. Now, what do you mean by the tap root modification? After becoming the tap root, primary root is there, branches are there, they slowly, gradually modify themselves for the function other than the primary function. Now, what is that other function than primary here right now? Storage in big amount now. Storage of food will be in big amount according to taproot modification, right? Then is for the respiration, then is for the nitrogen fixation. 3 functions other than the primary function is mentioned right now on the board. One is the storage, much more now, much ample amount of storage has happened, right? Then after that, respiration for the breathing purposes, then is for the nitrogen fixation. 3 are there here, right? Okay. So, some students are asking which NCERT should we use? Okay. So, in between, this is out of the chapter, you ask the question, at least you are asking something, means you are listening at least this part. So, let me to say this query what student asked. According to me, you should keep your old book of NCERT with you, but for any confusion, you must follow your old means a new NCERT book. New NCERT book you have to take, but the topics what have been deleted, it is not like that you should not read all the deleted parts. Some are there, you should still have to read, right? So for that you must refer your old book. For any confusion, like some concept is written in old book something differently, new book something else, then follow your new book. Keep both the books with you, right? And the old book, whatever you are having, that old book, what you need to read, what not to, that will be more clarified when you will be in the class. We keep on updating you that this topic you have to read and this topic you need not to touch, right? We are here to guide you all that thing, right? I hope so this doubt is clear to you. Vijay Lakshmi, please do give the response. Thrice you have asked this question. Okay, fine. So right now, coming back to the topic, we are talking about the taproot modifications. So first, we are talking about the storage, ample amount of food, respiration and nitrogen fixation. Coming on storage, you are having conical, fusiform, napiform, right? Carrot, radish, turnip. Common examples. Carrot, radish, turnip are there in front of you. Now, what do you mean by this conical form? Conical form means they are going to be broad at the base and tapering gradually like this. That form like a cone. This you call it as conical. And what example over there? Carrot will be the example. Fusiform means it is swollen in the center and gradually become taper on both the sides. It is swollen in the center and tapering towards both the sides. That is fusiform. And here example will be the radish. Napiform, example will be turnip. And napiform means it is much swollen at this point, at the base side, much swollen. But abruptly, suddenly becomes very narrow, right? When it becomes suddenly very narrow, then you call it as what? The napiform. When it becomes swollen in the middle, in the center or the middle region, but tapering toward upper and the lower side, that may become narrow, not tapering even, become narrow here. But here is completely tapering. This is very swollen at the base, suddenly tapering. That is napiform. Swollen in the center, narrow at both the sides. That is what thing? Fusiform, right? This is swollen at the tip, but becoming narrow towards the one end, only one end. Here both the ends. Here it become tapering towards one side, right? So there is a difference between conical, fusiform and napiform. And they are storing in that abundant amount of the food, right? Now here is it for respiration. These are found, like these roots you call it as pneumatodes, right? And on that, suppose this is the root under the ground, it is start moving upside, and they have the pores, you call it as pneumatophores. These are the pores which help in exchange of gases. In this case, the plants are in a swampy areas, right, or in the marshy areas. They are, example, if I write here, what example I must write, like in mangroves, right? So in mangroves category, Avicennia will be the example over there. Mangroves is a category of the plants which are growing in marshy or the swampy areas, which is having the water and the soil equal in its amount, right? So for the root, it becomes very tough to remain under the ground. They start growing upside. Can I say now they become negatively geotropic? I discussed in the beginning the roots are the positively geotropic, but here the this thorns, these are what? Negatively geotropic. So this is a modification. Now what function they are performing? The roots what have come out, what function they are performing? It is performing the function of respiration. Are you getting that? So here this is the basically means mangrove basically having taproot, but once they feel suffocating, they start giving up the modification of the root which start coming upside, that you call it as nematodes, and the pores you call it as nematophores. Now next is function nitrogen fixation, right? Nitrogen fixation, obviously fixing of atmospheric nitrogen. This is already, they have the taproot, and this is a feature of which family? For example, I am taking for Fabaceae family. This is a feature of Fabaceae family members. In their roots, you will find this nodules. Can you see here? These are nodules. This you call it as root nodules, right? And what is residing in this root nodules? They are having bacteria here. Which bacteria? Rhizobium. This is a symbiotic association. They are both helping each other. Plant is giving shelter to such type of bacteria, and bacteria in hand giving to them the nitrogen from the atmosphere, right? So now the roots are performing the function of nitrogen fixation, which is not common in all the roots. This is the root modification right now. Clear? So we have discussed the three root modification for taproot modification. First for the function of storage, then is for respiration, then is for nitrogen fixation. Clear? So this is about the modification in case of taproot. Now coming to the next part, adventitious root modifications. Right here it will include the purely the adventitious root, as well as it will include the fibrous root modification. I said you fibrous root when become mature, later it become the adventitious root. The first example shown here is for what function? Storage. But this storage is happening in the adventitious root modification, or you can say this example what I am going to write here, that is in case of sweet potato. Sweet potato will show the much more storage over there, right? They will, even the asparagus you can write, right? So these example can store the food, but they comes under the adventitious root modification, right? And if I am taking the example of the radish, carrot, turnip, it will come under the taproot modification. But if I am talking of potato alone, it will come under the stem modification. Sweet potato comes under root modification, but under which root modification? Adventitious root modification. Clear? So it will store more of the food over there, right? Now coming to the next point, extra support means they already are supported by their own organs, but still due to the full big crown on upside, they need extra support. Who is giving that extra support? These you call it as pillars, or you call it as prop roots, right? Here what is that? Both are for the extra support. This you call it as stilt root. Right? Pillar roots, in the beginning I already mentioned. What is an example over there? Banyan tree will be a very good example over there. See, these prop roots, they will move towards the earth. They are positively geotropic. But when you have learned about the mangrove plant in the taproot modification, that is negatively geotropic, and that is for the respiration, or I mean to say for breathing process, right? So for breathing, respiration, that what we are having there, the negatively you can say geotropic. But here for the support, it is start moving towards the ground, right? It is for the support. That one is for the respiration, for the exchange of gases, means breathing part we are discussing main there. So here for positively geotropic, and they are positively geotropic, that one is negatively geotropic. That is the main question you should know. This is even one of the comparison between that nematothodes and pillar or the prop roots, right? Now coming to the stilt root, here the example will be of maize and even of sugarcane, right? But do remember here, important thing, you can see it touching to the ground, but starting from the lower nodes. It is starting from the lower nodes of the stem part, right? So lower nodes, they are moving down, and how it is coming out? Obliquely it will come down. It is not straight like this pillar root. It will be obliquely, at angle will come down. But from which node? Lower node, not from upper nodes, right? So like suppose this is a sugar cane, you have nodes over there, but not from upper side, from the lower side, but obliquely down, to give extra support to this growing long stem over there, right? So what two things I have mentioned here? Pillar roots, stilt roots, this is for the extra support. What is an example of pillar root? Banyan tree over there. What is an example of stilt root over there? Maize and sugarcane, right? So which modification right now we have completed? Adventitious root modifications, right? So here right now we have completed with the root topic, and next we will meet in our next session, where I will take the next organ from this chapter. What is that organ? That will be stem. Then later we will take for the leaf. Please do revise that. It seems to be very easy chapter, but once it is coming in a form of question, again problem happen. The way I am telling you the terminology and through the pictures how to get your questions done, that all is very important, right? So all the best, all my students, and let's meet on the next session on the next organ of the flowering plants. Thanks a lot.